In this video, I'm going to go over sum and difference identities. I'm going to go over number 1 and 3 and hope that by the end of the video, you understand how to do these from beginning to end. One of the things you're going to need first is the formula that applies to this. So for cosine sum identity, it's going to be cos, and this differs from what you see, but the generalized form is cos A plus B is cos A times cos B minus sine A times sine B. Now, one thing you might have noticed is that we don't have A nor B, but we do have something in its place. Here it's pi over 4 and here's theta. So really, you just need to be comfortable with adapting with what you have versus and applying it to the formula itself. So my recommendation is obtain as much as you can and plug it into the formula as you go. And that's exactly how we're going to start our process. So if we begin, we should start by not writing cos A plus B, but rather what we have. We have cos pi over 4 plus theta. That means that our cos A is going to be cos pi over 4 times cos B, which is cos theta, minus sine pi over 4 times sine B, which is sine theta. Now, the best first step, in my opinion, is to do this, what we just did, so that you can really backtrack and ensure that you are filling in every component that you can. Now, moving forward, we're going to go ahead and now solve for what we can solve and then figure out what we don't have and then find it. So cos pi over 4, you should have, in the back of your mind, you should already have that cos pi over 4, which is 45 degrees, is 1 radical 2. Now, how do I know that this triangle is in the first quadrant? Well, it's just cosine pi over 4, right? If it was in the second quadrant, it'd probably give you something like cosine 3 pi over 4. So with that being said, now you go back to the basics of what is cosine. Cosine is x over r. And I'm not going to go that far back. You can watch another video on how to apply that. But x over r is going to be 1 over radical 2. This I'll do on the side. So x over r is going to be 1 over radical 2. But just to remind you that at this point, you should always rationalize, especially these special triangles. It ends up being radical 2 over 2. So that's our first one, radical 2 over 2. And then cos theta, in this particular case, the question is, are we given cos theta? Well, we go back here, and it says we're given cos theta. With that being said, chances are we're going to need to find the other trig function. So if you look over here, we're going to need to eventually find sine theta that we do not have. So with that being said, cos theta is literally ripped from the problem itself. This is what cos theta is. So we write it, and that is going to be negative 3 over 5. Right? That is directly taken from the problem itself. Now, another thing we have is the following. That is going to be that sine theta is positive, right? So just to remind you that sine is positive in the first and second quadrant, but because cosine is negative, that must mean that we're talking about the second quadrant because that's where cosine is at, right? So that's negative 3. That's 5. And if you can't figure out this other value that goes right here, which is what we need, you can always do the Pythagorean theorem. But sometimes you get used to seeing these numbers and you know right off the bat what is going to be. But just to let you know, you don't need to take the negative of this one. So remember, you need x squared plus y squared equals r squared. We are given x squared, which is 3 squared. Do you need the negative? Once again, no, just take the positive. So 3 squared is 9 plus y squared, which is what we do not have. And r squared is 25, right? I'm trying to save us some time here. Therefore, y squared is equal to, if we do Subtract that from there. So 25 minus 9, if we were to subtract that, it's 16. So therefore, y is equal to either plus or minus 4. Which one is it? Well, if you just remember, y is on the second quadrant, and in the second quadrant, y is positive. So as a result, we use positive 4, not negative. Had this triangle been in the bottom, third quadrant, it would have been negative, right? But how do we know again that it's in the second quadrant? Remember, this is why we have this particular formula. This cosine theta, sine theta tells you what quadrant to look at. So with that being said, from this graph, we can take that sine theta, okay, is equal to y over r, which is going to be 4 over 5. And there you go. That's how we came up with the next theta, right? You're going to need that. Now let's continue finishing this off. Minus and sine pi over 4, it's again referring to the same triangle, same thing. Y over r, and y over r is also rad 2 over 2. Times sine theta, we just retrieved that here on the bottom, and that's going to be 4 over 5. Okay? At this point, you're done with a trig. At this point, it is only algebra. So you should be able to simplify this. If not, use all your resources to be able to do that and double check yourself. But in any case, we'll do one term at a time. That is negative 3 radical 2 over 2. 2 times 5, which is 10, minus 4 radical 2 over 10. Now that you notice this, most of the time you will have a common denominator, and that means that you could just combine the terms. So in this particular case, do not forget that right here it's a minus 4, right? Had this 4 been negative, you would have had a negative times negative situation here, and that would have became positive. So please be careful with the sign. So here, if we add them together, it's negative 7 radical 2 over 10. And at this point, you hopefully can realize that there is nothing else to simplify. And we move on. So we're done with number 1. Number 2, same process, right? I'm not going to rewrite the formula. It's up there in green. But we're going to plug in as we go. So I do want to do that part because that's, I believe, should be standard. So I'm going to utilize this space here. But anyways, cosine, and in this particular case, it's going to be theta plus pi over 3. And I expand the formula. Cos A, which is theta, times cos B, which is pi over 3, minus sine A, which is theta, times sine B, which is pi over 3. And at this point, we just execute. So I'm going to do as much as I can. So that's going to equal cosine theta. Are we given cosine theta? In this case, we are not. So we must find cosine theta given this information here. So I'm going to do a little bit of math down here. So sine theta is negative, right? So I want to make sure I get my quadrant right. So sine theta is negative. This tells me that it's either in the third quadrant or fourth quadrant. Now I look at cosine. Cosine is positive. Positive means that it is going to have to be in fourth quadrant because cosine is going to be positive because the x-axis is positive here. So that means it's going to be the fourth quadrant. So I draw my reference triangle, and I fill it in. So sine theta is equal to negative 2 over 5. That's negative 2 here, 5 here. And now I do the Pythagorean theorem to figure out this one. If you could figure out in your head, great. If you can't, we'll do the Pythagorean theorem. So that's 2 squared plus, in this case, x. Whoops. Yeah, no, I'm looking at the right one. I got confused for a second because I thought I was looking at the bottom one. But I think I'm doing all right. Let me double check. Yep. So 2 squared plus, we're not looking for x squared in this case. We're looking for y squared, is equal to 25. So that means we're going to have y squared is equal to 21. I just subtracted 4 to the right. So then that means that y is equal to radical 21. Now this is an ugly number. However, you could just leave it as is, right? So this becomes radical 21. Can you simplify it? No, because 7 times 3 is the only thing you have, and thus you can't really break down that radical anymore. But in any case, no matter where you're applying this math, simplifying the radical shouldn't be the end all be all, so just move on. So with that being said, we're going to continue. So cosine theta, now we'd have it, but we're going to put it here for reference, right? Cosine theta is equal to x over r. So that's radical 21. I know that it's positive because look at the x-axis, and then the r is 5. So then that's what we're going to put here. So radical 21 divided by 5 times cosine pi over 3. Cosine pi over 3, remember, you can always and should always draw the reference triangle. Pi over 3 is 60 degrees, right? With that being said, radical 3 is here, 1's here, 2's here. That means that what we have for cosine pi over 3, it's going to be 1 over 2. Minus, continue on, sine theta. Sine theta, we're looking at this over here. Sine theta, we're looking at that right here. So sine theta is negative 2 over 5. And lastly, sine pi over 3. So I look at the triangle I drew at the bottom. My y is radical 3, and my r is still 2. And there you go. Now, one thing I did mention earlier that you should be careful of is this culprit right here. That might make you get the sign wrong. So because that 2 is negative, remember those two are going to multiply, and it's going to become a positive in between. So I'm going to start combining already. That's radical 21 over 10, right? Because 1 times radical 21 is radical 21. Plus, right, this is where you got to be careful. We have two negatives there. Plus negative 2 radical 3 all over 10, okay? Now, if I were you, if you really battled with this, I would just leave it here because you are 100% correct in terms of math. Is it simplified? No, okay? So I just want to clear that out, right? If you got to this point, chances are you're going to be 100% correct, but some people are going to want you to simplify it even further. But anyways, I'm going to just leave it as is, but I will combine it. So that's going to be, whoa, you see how what I did there? I noticed I wrote the negative. Why? The two negatives canceled out. There shouldn't be one there. So plus 2 rad 3, okay? And also right here we have all over 10. So you can combine it into one fraction. Again, it's not a big deal, but that's it. The next video I will do solving trigonometric equations, but for this one we have the sum and difference identities. So we'll leave it at that, and I hope this video helped.